and welcome to the mathleague YouTube channel. The following video was recorded by one of our staff members live at one of our contests.
Hey. Hello, everyone. Let's go over sprint 24. All right, good. So here's sprint 24. Parallelogram ABCD has these side lengths AB equals 17 and BC equals to 15. And the smallest area of a rectangle with integer side length that contains ABCD in its interior is 312. What is the area of ABCD? So we're given these side lengths here. And the first question we want to ask is, what is the smallest rectangle containing this parallelogram? Well, if we just take any old rectangle, we can't really deduce too much about it. But let's try to think about what a rectangle would containing this parallelogram would be. So in order to make the rectangle as small as possible, we'd want the rectangle to touch the parallelogram. And ideally, we would want to go along these edges as much as possible. So our ideal rectangle might have an edge going across like this, for instance. And we would want to make sure that the rectangle encloses the parallelogram as small as possible. So here are the corners at A and C, and some free hanging corners here and here. There's another possibility where the rectangle is like this instead as well. Goes along the other edges like that. And to determine which rectangle is smaller, we can use similar triangles. So this triangle here is similar to this triangle here. And to tell the larger triangle, we have hypotenuses of length 15 and 17. So since these triangles are similar, this triangle with the smaller hypotenuse would be smaller. So the green rectangle would have the smaller area. Okay, so now that we know that, we are given that this rectangle has area 312. Okay, so how do we find the area of the parallelogram now? Well, to find the area of the parallelogram, what we have to do is find the height, which happens to be the height of the rectangle here. So this is the height that we want to find. So we'll call it H. And this is H here. And let's call this length here A. Then, by Pythagorean theorem, we evidently have H squared plus A squared is equal to 15 squared, which is 225. And we have H, and then we have A plus 17 as the other side of the rectangle. So to use the area of the rectangle, 312, we want to have those two dimensions. H, and the other side length is A plus 17. Since we're given that the rectangle has integer side lengths, H and A both have to be integers, and this is a pretty large factor. And what we can do now is just take the prime factorization of this. So the prime factorization of 312, I think, is 2 to the 3 times 3 times 13. Check that. And we can check factors since this is greater than 17. The next largest factor after 17 is 24. So we just need to check all values of 8, all factors that are less than or equal to 13. And then we would want to plug in the values for H and A for each factor less than 13 when we do H and then A plus 17 here. And what we can find is that if we have this is, if we have this is 12 and this is 9, then 12 times 9 plus 17 is 12 times 6, 26, which is 312. And 12 squared plus 9 squared equals 15 squared, which you can recognize as the 9, 12, 15 triangle as well. So h is equal to 12, a equals to 9, and the area of the parallelogram, is equal to the height, which is 12, times the base, which is 17, which is 204.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.